So with that, I'll just say that my title is pretty grandiose, baleen whale sounds, but I'm really going to focus on the sounds that we hear in Southern California bite and the animals that we hear in Southern California bite. And don't worry, you're not supposed to be hearing anything just yet. So I'm going to start with blue whales. And blue whales that you can find off the coast here make two distinct types of sounds. One would be songs. They've been imaginatively called A and B calls, and that's what I'm showing here on this spectrogram. So again, this is the same kinds of things Simone was showing earlier. We have time on the x-axis and frequency on the y-axis. Mine aren't as pretty, they're just black and white, but still the blackness shows the intensity of the sound. So what we see here, this first set is this pulsing sequence. It's about 20 seconds long that has most of its energy right around here about 90 hertz, and then followed sometime thereafter by this tonal sound that most of the energy is actually here. You can see this one is about 46 hertz, and it's about 15-ish seconds long. And these, so this is the A call, the first one. The second one is a B call. And they can be repeated as stereotyped sequences. Sometimes there'll be A, B, A, B, A, B. Other times there'll be A, B, 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 A, B, B, B. So there's a little bit of variation, but not very much in what the animals do. And if you look at the time scale down here, so this is about 5 minutes of data. So there's about a minute or so usually between these repeated sequences. So that's also what we have here on the right-hand side. So we have a time series up here and a sequence down there. And when I was mentioning the frequencies here, 50 hertz might fall into that range that you think that you can hear, because everybody tells you humans can hear between 20 hertz and 20 kilohertz. But really, we can't quite hear it that low, or you need a really good subwoofer, and then you more feel your chest vibrate than anything else. So just for your listening pleasure, we've actually sped up the sound a little bit over here, so you can actually hear it. And I don't usually like to do this because this isn't what they sound like, but just so you can get some idea, I'm going to play, hopefully it'll work, sound over here. So that thing is actually the A call. And the second one is a B call. And you hear they're very short. That's because when you speed up the sound to increase the frequency, it also shortens the time. So they sound much higher frequency and shorter duration. It should really be more like a boom, 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 boom. So that's one type of a call that blue whales make. Down here at the bottom of the second panel is a different type. And as I said, these A-B calls are very, very stereotyped. They all look the same way every single time. The bottom panel shows also imaginatively called D call. And there are these down sweeps that last generally somewhere between 1 to 4 seconds. So they're shorter than these upper signals. And they have broader frequency range. This example shown here are from about maybe 70 hertz down to about 30 hertz, but they can be even higher frequency, up to 100 hertz down to about 30. And these tend to be produced by animals in groups that are feeding or socializing. Now the bottom panel, the D call, that type of call has been recorded by blue whales pretty much worldwide. The top panel, the A and B calls, are unique calls produced by animals off the coast here. You'll find them in animals up to about Gulf of Alaska and down to Costa Rica Dome, pretty much, as that population is moving up and down. But different populations actually have different types of songs that they produce. So what I'm showing here, this plethora of spectrograms, are different songs produced by blue whales in different parts of oceans and different oceans worldwide. So up here on the top left, again, is a California call that I was just showing and playing for you. So this is that A call. And you can see it a little bit better here because it's more stretched out. This pulsing sequence, again, most of the energy here at about 90 hertz. And then this long tone this is a very, very loud, nice example. A lot what you can see, this energy here at about 46 or 7 hertz is the most prominent one. And notice how blue whales off of Chile, which I'm showing on the panel below, look different. There's 3 sections to this call. Then these are somewhere along the equator, off of New Zealand, Midway and Wake Island in the middle of the Pacific. Again, very different, more just a flat tone, kind of even more boring of a call than the previous ones. North Atlantic, blue whales also make this low frequency long call, and the Antarctic animals as well. But some of the features that are unique for all of these is they're all very, very low frequency. A lot of this fundamental energy, especially here on the right-hand side of these panels, is below 30 hertz. They last more than 10 seconds generally. There's a little bit more variability on the ones on the left, but again, very, very long duration. Especially as I go through the others, you'll see these are some of the longest ones that baleen whales produce. Next, fin whale calls. And fin whales are quite similar in some ways to blue whales in that their calls are very, very low frequency. So again, I had to speed them up here so you can actually hear them. So I'll first play them back for you. So, like blue whale calls, they are often produced in these regularly repeated sequences, but the variation in fin whale calls doesn't seem to come in slightly different components because they're all pretty much these short down sweeps from somewhere in about 40 hertz down to about 20 or maybe 15 hertz, as we see here. Second long, again, very short frequency or very short duration, much broader bandwidth pulses. But what distinguishes different fin whale songs is the interval between these clicks. And sometimes they come in kind of these doublet pairs you can see here. There's this, let's call it narrower bandwidth call followed by a broader bandwidth call with a shorter interpulse interval than this next sequence where again you have a shorter and a broader bandwidth calls. So there can be some variation in the production of these units, but they're mostly consisting of these very low frequency broadband units. So the songs, again, will have this regularly repeated intervals. The other types of patterns in which this same unit is produced is as a call-counter-call, where it appears to be there's 2 animals that are kind of talking back and forth to each other, but the sequences tend to be more irregular. So on the bottom panel here on the right, you can see that there is now a whole bunch of calls. This is actually from a paper by McDonald and Fox, where they were able to localize on these animals and saw that there were in different, either different animals or different groups of animals, they were separated, and they seem to be basically talking back and forth. So the letters you can see up on top of the calls tell you which group that is and what was the bearing or the angle to that call. So there's at least a couple or 3 possibly individuals or groups of individuals talking back and forth to each other. So again, blue whale calls, very long tonal sequences. Most of the energy you'll be looking for is around 46 or so hertz for B calls and somewhere around 90 hertz for A calls. Fin whales, much lower, broader band, around 20 hertz and up. Next are Brutus whales, and similar to blue whales in some ways, Brutus whales seem to produce different call types in different places around the world. There was a paper by Olson et al. A few years back that showed quite a bit of variation in their calls across the eastern tropical Pacific, but then also in other locations. And the panels here on the right show, again, the variation in Brutus whale calls in all those places. Most of them are in ETP. But notice the energy, again, is mostly somewhere for these tones. It's about 30 to 50 hertz. They're tones, but they're about a couple of seconds long. So this is kind of intermediate between blue and fin whales. The fin whales are really short and blue whales are very long. And mostly what we see off of California is this BE4 call but also occasionally the BE2 seems to sneak in to our area. Also, in some places, they make these downstroke calls. I don't think we've seen those out here. Humpback whales, you've probably all heard humpback whale song at some point or are familiar. If anybody's heard any whale, this is probably it. Their songs tend to be fairly complex, made up of different phrases that then form themes, and these themes can change over time and also vary geographically. So let me first just play a little sample. So now, humpback whale song is, well, I would consider it high frequency, but some people might disagree. It generally starts, a few hundred hertz and then goes up to maybe a couple of kilohertz. They can have components that are pretty low, below 100 hertz range. So because it is so high, I didn't have to speed it up or do anything fancy to it. You can just actually hear it. Which I think another part of the reason why people like humpback song, because you can hear it. So a lot of these songs tend to be produced by males, mostly in the winter breeding areas, although they do produce them also in higher latitudes. But we've known for a long time that the pattern of this song changes over time, and what I'm showing down here on the right-hand side is an example of evolution of a song, where this is, again, just kind of a sketch of a spectrogram. You can again imagine time on the x-axis and frequency on the y-axis, and these wiggled here are different, basically, phrases of a song. So you can see how from the mid-70s to early 80s, this simple phrase consisting of two of these themes and then, or two of these phrases and this one, got more and more complex, adding more phrases until it turned into a much longer and a much complicated thing. And this seems to be something that happens with the humpback song quite a bit, which unlike previous baleen whale calls that I described, that are very stereotypical and don't seem to change much over time, for the most part. Humpback whale song is much more flexible. Next are minke whales, and minke whales, like most of the others, produce different call types, different sounds in different oceans. So out here in the Pacific, they seem to make boings, and let me play a boing for you. So that's an example of a boing that you would hear here in Southern California Bight. The spectrogram here on the right-hand side shows a San Diego boing versus a Hawaiian boing, and there are some differences, seems geographically, even between those boings. But then minke whales in the Atlantic make different sounds. They make these pulse trains, and this again has been sped up because it's a little bit low frequency again. They could probably hear it anyway, but so it's that rapid pulse, basically. And let's see, finally, oh no, not finally, gray whales, again, are another species that makes some sounds. They're actually not as vocal, I would say, for the most part, as the other animals are. But most of us are familiar with their migration pattern coming along the coast of California, and their calls have been classified into the calls they produce in feeding grounds versus migratory path versus down in the lagoons in Mexico. So these are the different migratory signs, some of them which they make in multiple occasions. But first I'll play the fun one. Unfortunately, that's not the sound that they make most of the time. Most of the time, they just make this other little sound that was so not exciting, I'm not even going to play it for you. That's known as the M3 sound, and that's what we've been seeing most commonly in our data looking for gray whales. And there's also been other types of pulsing sounds that they produce. But again, unlike some of the larger baleen whales that I described, gray whales do seem to have more variety and a little bit more complex sounds, even though they're not nearly as vocal as the others. So that's all the baleen whales I have. I also throw in one pinniped just because they're low frequency as well. And you will often, if you get recordings on the California bite, you will often hear sea lions. And mostly what you hear are barks. They're pretty much the same barks that they make above surface that you can hear when you're just walking somewhere and there's a bunch of sea lions around. They make them both in and out of water. And they're made by males, probably various dominant and aggressive in place. But there's also whiny or buzzing sounds that are not quite as common. So with that, I want to thank you for your attention. And the quiz is coming up in 15 minutes. I think we get a break now.